This lesson is on covalent bonds and Lewis dot diagrams. Let's review quickly. Covalent bonds are bonds in which atoms share electrons. They're not giving electrons away, they're not taking electrons from each other, they're merely sharing electrons. And what a Lewis dot diagram is a Lewis dot diagram is basically an illustration of how two atoms come together to share electrons in a covalent bond. So it's just an illustration of how those two elements come together. There are two different ways, or three different ways, that atoms can come together to form covalent bonds. The first is a single covalent bond in which only two valence electrons are shared. In a double bond, double covalent bond, 4 valence electrons are going to be shared between the two atoms. And in a triple bond, 6 valence electrons are going to be shared between the two atoms. Now, after understanding what a covalent bond is, there's another type of covalent bond called a coordinate covalent bond. Typically, in a covalent bond, one atom will donate 1 electron, the other atom will donate 1 electron, and they'll share those 2 electrons, one coming from each atom. But in a coordinate covalent bond, one atom actually donates both electrons. So 2 electrons are coming from one atom and being shared with another atom without the other atom donating any electrons to that sharing relationship. So that is a coordinate covalent bond. The overarching rule that determines how you draw a Lewis dot diagram structure is the octet rule. The octet rule states that all atoms in a covalent bond want to have 8 electrons in their valence shell. Having 8 electrons in their valence shell gives an atom a noble gas configuration, meaning they're more stable and they're less reactive. They're trying to all reach the overall goal of a covalent bond is to obtain 8 electrons in your valence shell. The exceptions to this rule are hydrogen and boron. Hydrogen is such a small atom and it only has 1 energy level around its nucleus, therefore it only wants 2 valence electrons. And boron is also a very small atom. It only wants 6 valence electrons in its outermost shell. So, with all that said, let's practice drawing some Lewis dot structures. Our first example is nitrogen trifluoride. Nitrogen trifluoride is obviously a covalent molecular compound. The first thing you need to do is figure out how many valence electrons are we actually working with. And what you know from previous lectures is that the group number or the family number, the column that each element is in on the periodic table, indicates the number of electrons in the outermost shell. So nitrogen is in group 5, meaning that it has 5 electrons in its valence shell. Fluorine is in group 7. It has 7 electrons in its valence shell, and there are 3 atoms, so we go 7 times 3 is 21. There are 26 total valence electrons in this molecule. Okay, when drawing your structure, the first thing you need to know is which one of these atoms is more electronegative. That chart can be seen in your book. Remember that electronegativity is the amount of pull that atom has on electrons in a covalent bond. So some atoms pull on electrons stronger than others. In this case, the atom that is least electronegative is nitrogen, meaning it has the least amount of pull on those electrons. So nitrogen will be in the center of our molecule, and we're going to go ahead and surround it by fluorine atoms, which are the most electronegative. Now we know that these are bound together somehow, so we can go ahead and draw those bonds into our Lewis dot structure. And we have used 1, 2, 3, 4, 5, 6 electrons because each of those lines indicates that we have used 2 electrons. So 26 minus 6 is 20 valence electrons. We have 20 left to use. The most electronegative element will then get the remainder of the electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 electrons we have used. There are 2 valence electrons left, so we'll go ahead and place those on the nitrogen. Now let's go ahead and check the octet rule. 1, 2, 3, 4, 5, 6, 7, 8. This fluorine is satisfied. 1, 2, 3, 4, 5, 6, 7, 8. This fluorine is satisfied. 1, 2, 3, 4, 5, 6, 7, 8. This fluorine is satisfied. And 1, 2, 3, 4, 5, 6, 7, 8. this nitrogen is satisfied, and this is the Lewis dot structure for nitrogen trifluoride. Our next example is carbon disulfide. Carbon is in group 4, so it has 4 valence electrons. Sulfur is in group 6, it has 12 valence electrons. Add this together, and there are 16 total valence electrons in this compound. The least electronegative element in this compound is carbon, which will go in the center, surrounded by sulfur atoms. We know they're bound together somehow, so you draw the dashes between them, each indicating 2 electrons have been used. So we've used 2 4 electrons, leaving us with 12. And we can go ahead and place those on the most electronegative atoms. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 electrons have been used, and we are left with 0. Let's go ahead and check the octet rule. 1, 2, 3, 4, 5, 6, 7, 8. This sulfur is satisfied. 1, 2, 3, 4, 5, 6, 7, 8. This sulfur is satisfied. 1, 2, 3, 4. Carbon is not yet satisfied. Where do those electrons come from? We're going to ask sulfur to be a good friend and share its electrons with the carbon. Let's go ahead and check. 1, 2, 3, 4, 5, 6, 7, 8. This sulfur is again satisfied. 1, 2, 3, 4, 5, 6, 7, 8. This sulfur is again satisfied. 1, 2, 3, 4, 5, 6. Carbon's not yet satisfied, so where do those electrons come from? We're going to ask the other sulfur to share its electrons. And now, this sulfur is satisfied. 1, 2, 3, 4, 5, 6, 7, 8. This sulfur is satisfied. 2, 4, 6, 8. Now the carbon is satisfied, and this is the Lewis dot structure for carbon disulfide. Notice it has 2 double bonds in which we are sharing 4 valence electrons each. Our last example is Cn with a negative charge. This is a polyatomic ion called cyanide. The least electronegative element here is carbon. So carbon is technically the central element, even though there's only one other atom bound to it, which is nitrogen. Nitrogen is more electronegative than carbon. It has a stronger pull on those electrons. They're bound to each other somehow. Oh, first we need to figure out how many electrons total are in this compound. So carbon's in group 4. Nitrogen is in group 5. That equals 9 valence electrons. But this negative charge on the cyanide indicates that it has 1 extra electron. So we'll add 1 electron to this molecule, and the total is 10 valence electrons. We've used 2. 10 minus 2 is 8. Go ahead and place those extra electrons on the most electronegative atom. Now we've used 6. There's 2 left over, which we can place on the carbon. Now let's check the octet rule. 2, 4, 6, 8. Nitrogen is satisfied. 2, 4. Carbon is not yet satisfied. So we're going to ask that nitrogen to share a pair of electrons. Now carbon has 6. Still not satisfied. So we'll ask nitrogen to share again. Now carbon has 2, 4, 6, 8. And the carbon is satisfied. This is the Lewis dot structure for cyanide. In order to complete it, you need to place brackets around and indicate that you added 1 extra electron by showing that the whole molecule has a charge. Our next lecture will be on resonance structures and the expanded octet.